Okay, let's see the abstractness of all these data structures. Let's see just one example. Let's say we have L, that's the list. We have already tuple, that's tuple. Let's say we have set, that's set. Let's say, and we have dictionary, that's a dictionary. Okay, so let's say we have all these things, let's say, available somewhere. So let's make another dictionary. For example, let's say let's say D2, and that dictionary has key value pairs. Let's say the key is A and the value is the whole list L. That's the value. It is possible. Let's say the key is B and the value is just a tuple, the whole tuple. That's the value. Let's say the key is C and the value is the set. And let's say the key is D and the value is the dictionary, the whole dictionary D. It is possible. I mean, you can just do that. That is just one example. Oh, sorry. I should have incorporated this way. Okay, so this is possible. Now, for example, if I access the element with let's say A, I will get the whole list. And not only that, I can access the whole element, and then after that, for that element I can access, for example, the third element, the element at index 3. So this particular first level will extract the list, and that is just the indexing or for that list. See, for example, if I access D2 and inside D2, if I access the dictionary that is inside, and let's say I save that dictionary in K, then I can see the contents of K, but I can just, for example, this, or I can just access all the elements of this dictionary or K by just having for X in K, print, for example, X and K of X. Just do that. I can just do that. We have done that in loops as well. So I want to tell you that these even if, for example, if you want to create a list L, let's say L3, let's say you want to create a list that can contain the whole list, that can contain I mean, one element is the list, another element is a tuple, another element is the whole dictionary inside, and then you have some other elements, let's say these game, and that's perfectly fine. I mean, you can do that. These data structures are much more abstract. I mean, now if you, for example, access element at index 2, which is dictionary, that is completely a dictionary. If you check the type of that element, that will be a dictionary object, and you can extract that element and play the way you want to play and whatever. One more thing, we can, for example, lists, we can let's say we want to make a list very quickly. For example, list of all the squares till starting from 0, list of all the squares till 10, for example, 0 square, 1 square, 2 square. Let's say we want a list of that. So one way of doing that is, a quick shortcut is to just use the loops. So in loops, for example, we write, okay, x square for x in range 10, for example. So it will start from 0, go till 9, including 9, and you will get x one by one, and all this syntax is for making a list of x squares where x starts from 0 and go till including 9, go till 9 one by one, and that's how you can make a list. And I mean, these are kind of shortcuts. Again, you can make a set, for example, let's say you want to make a set of all the squares for x in range let's say starting from 2 ending at 20, and you want to take a step of, let's say, 3. So start from index 2, go till 20, do not include 20, but take the step of 3, and you can now have a set which is this. I mean, there are a lot of ways of working with these. One can explore more and more about these things, but what the basic thing about these data structures are, they are very, very abstract. They can, I mean, a list can contain a dictionary, and that dictionary can contain a tuple, and that tuple have an element which is another list, and so on. It is that abstract. It allows you to do each and everything in that way. Okay, so I end this video here. In the next video, we will actually solve a problem using these one of these data structures, or we will try to choose one of those. And that video may be lengthy, may be small, because we may have bugs inside, and we will play around with these data structures in the next video. So do attend the next video, because it's really the practice, and you will get your hands. You will get a very good grip on the data structures in solving the next problem that we are launching for you. Okay, hope to see you in the next video. Okay, let's see a problem just to get comfortable with these data structures. So let's design some problem and solve that problem here using these data structures. So the problem that I'm thinking is, let's say, the following. Let's say you are a teacher. Should I type all these things? Okay, yeah. Let's say you are a teacher. You are a teacher, and you have different student records containing ID of a student, and the marks list in each subject, where different students have taken different number of subjects, and all these records are in hard copy. You want to enter all the data in computer and want to compute the average marks of each student and display. That's the problem. So the problem, let's say, is you have, for example, you have a hard copy, you have some papers upon which you have different students. Each student have a different ID. Some students may have taken 7 subjects, some student may have taken 3 subjects, some student may have taken 8 subjects, and so on. Different students may have taken different subjects. The records is there. You want to first enter, for each student, you want to first enter the records, I mean all the data that is in, and then you want to compute from that data, you want to compute the average marks of each student. For example, if a student have taken 5 subjects, then the marks for all the 5 subjects are available. You just add all the marks and divide by 5, and that's, let's say, the average marks. So first of all, let's write a way to compute, for example, to just collect the data, how to collect the data. So let's write a function for that. So let's say define a function, let's say get data from user or teacher, let's say, and let's say that's a function. and it returns data. Okay, so what I do really is I say, okay, while true, I made a loop while true, just take the data from the user, and the data is in the form of you first say, okay, ID, student ID, let's say that is enter, or actually input, enter student ID. So he enters the person enters the student ID. Yeah, so on top you might have defined a dictionary, maybe a dictionary D that is empty right now, but you may add and remove different values. So what you do is you add a student ID, you get a student ID and in the string form, and then you get the you get, for example, the input as the marks list. So marks list as input, enter the marks by comma separated values. So enter the marks using, for example, if you have 5 subjects, just write the 5 subject marks by separating each with the comma. Okay, then let's say more students is equal to, let's say, input enter yes or no for adding more students. So if, for example, you have more data to insert, then press yes, otherwise press no. So that's, for example, our setup. So we will keep on getting more and more, we will keep on getting more and more data from the user will keep on entering the data. But one thing that we must know is that if, for example, a student ID is already in D, if that is already in D, then we should give a message, print that student ID is already inserted. So that might be a message. Else we want to do something else. What we want to do is the following. What we want to do else is we will make a dictionary. We already have a dictionary with the student ID as our key. That's our key, and at that key what we do is we pick the marks list and just split it using comma, because we are expecting, and all the marks, they will be saved as a list. So that will return a list of string values. These are not integer values, these are string values, but all these lists, they are tagged by this ID. So that is a dictionary that will be getting populated on and on and on. Further, if we check if for example, more students dot lower, for example, let's call the lower function because the user may enters it in a lower form, or if that is equal to, let's say, no, if that is equal to no, if this is the case, or if that is no, enter, for example, no, enter no, enter no to quit, insert. insertion, enter no to quit insertion. So let's say that's your message. So wherever the user inserted, if that's a no, then you return D and that's it. Otherwise you keep on moving. So that's the whole code. So you keep on asking you keep on asking more and more values. If whenever the teacher enters a no, then you just return. Otherwise you make another iteration, and keep on moving. That's how you get the data. So the data will be available to you once you are done with that. Then after that we will see how to, once we have this data collected from the user, then we will see how to compute marks for each student individually, average marks and so on. So let's just check whether this function works or not. So let's say we have our dictionary. Let's say student data is equal to get data from user. Let's just call that function. And let's see what happens. Okay, enter student ID. Let's say ID is 12. Okay, enter marks by comma separated values. Let's say 12, let's say 24, comma 65, comma 87. Let's say the first student just have these 3 subjects. Then enter no to quit. So I will enter something else. And oh, what's the problem? There is a problem. If more students dot lower is more student is not defined. More student, that's, I guess, more students, more student here. Oh, the spelling mistakes, that's a huge mistake. So I just copy there. These bugs are there. That's part of life, part of programming life actually. So I guess now it will work. So let's do the process again. So 12, let's say, and the marks are 56, comma 45, comma let's say a bad subject with, let's say, 13. Enter no to quit. No, I will enter something else and I will keep on moving. The other student is the student ID is 45, let's say, and the marks that this student has gained, actually let's say the student has already registered 7 subjects, or let's say 5 subjects, and the marks are, let's say, 44, 55, 66, 77, and let's say a bad subject, let's say 4. Okay, then enter no to quit. No, I want to insert one more, so do anything else other than no. So student ID, let's say now the student ID is 12 again. Let's say I want to insert another ID again, and whatever the marks, let's say 45 and 45 again, let's say. Now enter no to quit, no something else. But now the message is there. The 12 is already inserted because the ID, the key value in dictionary cannot repeat, and so is the student value. So it does not inserted because this may be by mistake. So it asks again. So now let's say I enter ID, let's say 23. That's the ID, or maybe a different ID. That's the ID, and the marks are, let's say, 45, comma 45, let's say, and enter no to quit. So let's say I enter no, and that's it. So now I have received the student data. If I show you the student data, that student data is student data. That's a dictionary. That's a dictionary with key 12, and that's a list. But this list contains all the values that are string type. We will see how to handle that. That's a 45 as a key value. That's ID, and that's the marks list, and that's the ID, and that's the marks list. Okay, great. Now we have student data. Let's write another function that helps us working on the student data. Basically, we want to find out the average marks of each student, and then we want to print those. So let's define another function, get average marks of each student, and that function actually receives this dictionary. Let me call it as D. Any variable, that's a local variable. Okay, so what we want to do with that is the following. Average marks for each student. So we will define another dictionary. Let's say average marks dictionary. Let's say that is empty in the beginning, maybe. And then what we do for x in D, let's iterate over x and D. What we really do is we go to we find out the list of located at L, located at X. So L is basically D sub X. So let's say that's our list. That's our list that is located there. So then what we do for I in L, so for all I that is in L, or let me call it for marks in L, in this particular list, what you do is you actually have this sum. Sum is equal to 0. Right now there is no marks, so what you do is s plus equals to marks, but convert the marks to integer because they are already in string format. We have saved everything in string format. So you populate all the list. Once you are done with this loop, the s will contain the sum of all the marks. Then what you do is you compute the average and just save that average in avg marks dictionary, let's say, or average marks. Just don't use the word dict, for example. You can, but let's stay casual. And at x you just write the average marks, and the average marks can be computed by s divided by length of the list, whatever the list is. So that's what the list is. Yeah, so that's the average marks. And once you have, and one by one all the average marks will be populated, and once we receive all these, we will then we can then just display by populating the average marks. So let's see, let's call that function. So let's call that function. So avg marks, for example, equals to get avg marks, and let's plot the student data inside, and if there is no error then it will return everything. Then just print the average marks for each student for x in avgm, print, let's say student, and then print x got average marks as, then you just print okay, avgm of x, x, and that will display everything. Oh, if there is an error. None type object is not iterable. None type object. Why none type object? We have done some mistake. Yes, maybe. Let's see, for example, when we have run this. So let's run this and create a cell. Let's run using alt enter. It will create a cell, average m. What is that thing? Oh, that is nothing. Why? Oh, we haven't returned anything. That's a bad programming, really bad programming. We have not returned actually the value that we need. So the default value is none. Great. Actually not so great. Okay, great. Yes, this. And now we have something in average marks. Yes, this is. And now we can just populate that, and we have the student 12 got average marks 38, student 45 got average marks 49.2, and student 23 got average marks as 45.0. Okay, great. So that was just a review of split function of string, type conversion through int, and functions in general, input function, and dictionary and list and all that stuff. So although it was just a tiny problem, but it gives a good flavor of the data structures and strings and all that stuff. Okay, that's about the data structures. From the next video, we are actually diving into the data science packages, and we will start from NumPy, and we will spend some time on NumPy, and then we will be moving towards Pandas, which is very powerful, built on top of NumPy, and after that we'll be moving towards Matplotlib, and we will also